Hello, welcome everybody. In this occasion, we are going to deal with the last video of this unit, and we are going to talk about the properties which could be conferred to textiles due to the application of 3D nanostructures on textiles. Well, as we have seen at this moment, we have studied that a nanostructure in 3 dimensions could be a structure with nanometric dimensions on each direction. And we have seen that we have the possibility to insert different kinds of particles. The most commonly used at this moment are the ones that we saw in the previous video, that were silica, silver, zinc, titania, copper, chitosan. We've got many particles, but those are one of the most extended. And we can find that there are many properties which are conferred because of these products, okay? For example, we could observe that, for example, silver and chitosan nanoparticles would confer antimicrobial properties to the textiles. But if we use titanium dioxide, it could confer ultraviolet protection to the textiles. Or, for example, if we use zinc, it also would use or implement antimicrobial properties or whatever. So we can observe that it's not necessary to introduce only one property, okay? We can use these particles to confer more than one property to the textiles. So, among the most commonly properties that are an interesting field on textiles, we can cite antimicrobial, ultraviolet, improve the tensile strength. For example, if we use some kind of silica particles on the extrusion process, we would find that some of them could improve the tensile strength of the fiber, but we also can try to look for water repellency, fire resistance, self-cleaning properties, etc. As an example of how does it works, we are going to talk about water repellency effect. In this occasion, we are going to talk about nanoparticles which are going to confer, for example, water repellency, and this is based on the Lotto flower effect, okay? The surface of this Lotto flower is made of many little mountains or irregularities on the surface of this flower. So this means that due to these irregularities that we can find on the surface, the irregularities are nanometric, and this means that when one drop falls in the leaf, then it has not enough surface to contact and then it's spoiled out. The same happens when we treat a textile in that way. For example, in the image on the right side, we could see that we have cotton fibers treated with titanium dioxide nanoparticles, okay? In this case, we can see that there are some of them which are big, and this is because of the presence of the binder that made an agglomeration so that some nanoparticles were sticked one to another, okay? But those nanoparticles applied on the textile surface that we have on the screen means that the cotton fabric would have improved the water repellency effect. But as I have said in the previous slide, for example, titanium dioxide has more properties than the one created by the effect of the nanoparticles on the surface. Because of its chemical structure, titanium dioxide is also going to implement different properties such as ultraviolet protection or, for example, self-cleaning properties, okay? As the titanium dioxide could be considered a photocatalyzer, we are going to find that it's going to help to remove part of the dust of dirty products that we can find on the fiber surface, okay? So in this case, we could observe that this nanoparticle is going to introduce different products, different properties. Well, at this point, what I could do is to invite you to do some research or to conduct some research on the different properties that nanoparticles can confer to textiles. Thank you very much for your attention.